Okay, so we're going to do solving equations here. I don't know why my screen looks like that. That's very strange. There. Okay, so solving equations. So in the past, what we've learned about is relations and expressions. So before we start solving equations, we have to remember what an expression is. This is an expression, and we have to remember what does it mean? 2x. What exactly does that mean? That means, make a little arrow here, 2, whoops, that's supposed to be a t, times a number. Okay, you can remember some of the other ones. This is 2 more than a number. Do you remember this? These are expressions, and the value of x can be anything, and we can evaluate that expression. Let's look at a couple others. X minus 5, 5 less than a number, and so on. Okay, oh, and there's another one here I should probably put. X over 2. This is a number divided by 2. Okay, and remember how we evaluated those? So now let's evaluate them. You evaluate for x equals, let's say, 8. Okay, so 2x, we can evaluate that. So here I'll evaluate. 2x is 2 times 8, or 16. X plus 2. Evaluate for x equals to 8. That's 8 plus 2 equals 10. Evaluate 5 less than a number. If the number is 8, 8 minus 5 equals 3. A number divided by 2, 8 divided by 2 equals 4. So we can evaluate those, and those are not equations. You can say, hey, we're supposed to be solving equations, but expressions make up part of the equation. Okay, so what is this? Expression or equation? A, B, C, D here. We got 4 examples. Some of these are expressions and some are equations. A and C are different than B and D. What's the difference? A and C do not have a defined value for y or x or for y. They can be evaluated for anything because that expression doesn't equal anything. But as soon as I get an equal sign, then I have something called an equation. So that means that the variable can only have one value. It has to be equal to something. And so algebra is the idea of solving an equation through a system, a methodical system. But what we're going to be doing today is called guess and check. Okay? This is a strategy. It's not a system. It's a strategy. Sometimes it won't work very well for you. And that, for those harder problems, what we're going to do is develop a system. But for today, we're just going to simply use guess and check. So look at these 2 that are equations. If they're an equation and you have a variable in it, we can determine what that variable is. And we're going to use this strategy. We'll try off 3x minus 1 equals 5. So what we're going to do is, first of all, look at the left side of the equation. I'm going to highlight that in blue. This side has a variable. The right side does not. This is a constant. So what we're going to do is evaluate the left side, like we did back over there before. When we did evaluation, we evaluated for x equals 8 here, and find out its value for x equal to a certain number. We're going to evaluate the left side, eval this, and see if it equals the right side. And now I could also just write 5 equals 3x minus 1. It's the exact same thing, so I shouldn't always say left and right, but this happens to be on the left. So we're going to use guess and check. We're going to try a number, and we're going to see what it gives us. So that's a simple thing of substitution. Let's start off with the number 1. Change my pen to red here. What if we eval for x equal to 1? Then we'd write 3 and put brackets 1. I'm putting brackets 1 because it doesn't want to look like 31. That would be confusing. minus 1 equals 5. And we see if this is a true statement. So we have to use order of operations, don't forget that. Do multiplication, then addition or subtraction. So 3 times 1 is 3. I'm going to simplify that. See how we did that? That becomes 3. Write out the rest that hasn't been done yet. 3 minus 1. 3 minus 1 is 2. Does 2 equal 5? 2 does not equal 5. So that breaks the law. We can't do that. So it can't be x equal 1. So then we have to see, all right, well, x was, if it's 1, I get 2 on the left-hand side. And think of it as like a scale, okay? I've got a scale here. If I have 2 over here and I have 5, this side's going to be down. That means this side needs to get heavier. It needs to get bigger, okay? So I have to make x be something slightly larger. So let's try, I don't know, 3. All right, so I'm going to evaluate for x equal 3. Try that. So 3 brackets 3, so that's 3x, minus 1 equals 5. Let's evaluate that left side and see if it equals the right side. 3 times 3 is 9, minus 1 equals 5. You can see right away this is not right. 8 does not equal 5. So here we chose a number that's too high. Before we chose a number that was too low. So to get that correct balance, all right, what we're going to do is then go back down and we'll try for x equals 2. Okay, I'll write it out. 3 brackets 2 minus 1 equals 5. 5. There we go. 6 minus 1 equals 5. And is this a true statement? Yes. 5 equals 5. That means we got it. So to review what we did, we tried out a number, substituted it for x, and we evaluated the side with the variable to see if it equaled the side with the constant. And here it did not. It was too low. So then we tried a much higher x, a little bit higher x. So we evaluated for x equals 3, and we evaluated the left side, and it came out 8 equals 5, which was too much. It did not balance out. So then we tried backing it down to 2, and we got it. Okay, that's guess and check, and we can use that strategy sometimes, many times, and it will work okay. Okay, quick, guess and check. 3.5x is equal to 2.758625. No, that's not going to work. So we don't always use guess and check, but for today, we're going to be working with simpler problems where you can use systematic inspection or systematic trial to figure it out. So let's do some more like that. Okay, before I said guess and check, but you know what, it's really more something like systematic trial, where you have a method to your madness. It's not just random checking, and you know that. When you do guess and check, it's not just, I'll throw out a number, 2 billion, oh, that didn't work, 59 million, no. It's going to have some logic to it. So let's say we have to solve this equation, 2x plus 5 equals 37. I want to solve it by systematic trial. So I'm going to start off with a value for x. I'm going to see what happens. Okay, so let's say input x equals 30. Okay, I'll evaluate it. So that means substitute x. Instead of 2x, it's going to be 2 times 30. Write that out. Okay, plus 5. That's going to be equal to, oops, that looks funny. That's going to be equal to 60 plus 5, or 65. Is it too large, too small? Too large. So that means I'm going to try a smaller number. Because if it's too, my evaluation on the left side is too big, bigger than on the right side, and it is here, 65 is much more than 37, I'm going to have to reduce the size of x. So let's try x equals 20. And I'm doing this not randomly. I'm not going to say, oh, 30 didn't work, so let's try 3,000. I'm using my noggin. So 2 times 20 plus 5 is going to be 45. It's still too large. 45 is not equal to 37, it's greater. Okay, so now I'm going to try dropping it down. How about x equals 5? I'm tired of this. I'm going to go lower. See what happens. 2 times 5 plus 5. Well, that's only equal to 15. Now I'm too small. So here I could throw up my hands, or I could use some clues here. I was too large, too small. That means somewhere between 20 and 5 has got to be my answer. So I'm going to start going back up. X equals 10. Okay, 2 brackets 10 plus 5. That's going to be equal to 25. I'm getting closer, but it's still too small. I'm going to try now x 15. 2 times 15 plus 5 is equal to, close, 35, but it's still too small. So here I'm going to use my brain here. I'm getting fairly close. I'm really, really close. I just need one more group of 2. So I'm going to try x equals 16. 2 brackets 16, that's going to be 32. 2 times 16 plus 5 will equal 37. And it's just right, like Goldilocks. Okay? So I've solved my equation, my original equation. 2x plus 5 equals 37. X must be equal to 16. That's called systematic trial. And so that's what you're going to do for guess and check. It's not just random guess and check. That would be silly. But I'm going to get you now to answer some questions in the quiz using guess and check. That means that you can answer all of them through systematic trial. No, I'm not going to give you 3.5 is equal to x is equal to 2.787. That wouldn't be very applicable. You can use algebra for that. For now, we're just using guess and check to solve equations. And that is all.